Some of the rarest gemstones on Earth look completely unimpressive, not brilliant, not colorful, sometimes not even recognizable as gemstones at all. One of them resembles a dull piece of gravel. Another spent decades being mistaken for a far more common mineral. And one gemstone was once so rare that scientists believed only 3 crystals existed on the entire planet. Nothing about these stones suggests how extraordinary they really are, because their rarity isn't obvious. It's hidden deep inside the chemistry of the Earth, in geological conditions so unusual that nature almost never repeats them. The result is a strange category of gemstones, minerals that appear ordinary at first glance, but turn out to be among the rarest objects the planet has ever produced. Today's countdown explores 10 gemstones that challenge one of the oldest assumptions about beauty and value. Because in the mineral world, the stones that look the least impressive can sometimes be the hardest to find. Starting with a pale crystal that most collectors would overlook, until ultraviolet light suddenly changes its color. Ranked 10th, Hackmanite, the stone that changes its mind. Place a pale piece of Hackmanite under normal light and it barely attracts attention. But expose the same stone to ultraviolet light and the color suddenly deepens, shifting toward violet or pink as if the crystal itself has decided to change its appearance. For a gemstone that looks so ordinary that behavior feels almost impossible. At first glance, Hackmanite rarely impresses anyone. In a tray of gemstones, it often appears pale, chalky, sometimes almost dull. The surface lacks the deep sparkle people expect from gems. The color can look washed out, somewhere between soft lavender and dusty gray. Most collectors scanning a display case would pass over it without hesitation. But Hackmanite has a secret, and that secret only reveals itself when the lighting changes. Expose this quiet mineral to ultraviolet light, and something remarkable begins to happen. The stone deepens. The color shifts. What once looked faded suddenly develops a richer tone, sometimes violet, sometimes pinkish purple. This unusual reaction is known in mineralogy as tenebrescence. Unlike fluorescence, where color disappears the moment the light source is removed, tenebrescence allows the stone to temporarily hold its new color, as if the crystal structure briefly remembers the light it absorbed. Then slowly the color fades again, almost as if the stone is reconsidering its own appearance. Hackmanite belongs to the sodalite mineral group, but only certain rare deposits contain the structural imperfections required for this reversible color change. Those deposits are surprisingly limited. Significant specimens have been documented in Greenland, Afghanistan, Myanmar, and Quebec, but gem-quality pieces remain uncommon, especially stones that display strong, tenebrescent behavior. For gemologists, Hackmanite represents something fascinating about the mineral world. Beauty in gemstones is often associated with permanence, color that stays stable, brilliance that never changes. Hackmanite challenges that idea. Its value does not come from immediate visual impact. It comes from behavior, from the way the stone interacts with light, and from the rare atomic conditions required for that interaction to occur. In other words, the stone's true character only appears under the right circumstances, and that makes Hackmanite a perfect reminder that rarity in minerals is not always obvious at first glance. Some stones reveal their secrets immediately. Others take a moment of curiosity and a change in light. Before moving to the next gemstone, consider this. If a mineral looked completely ordinary under normal lighting, but transformed the moment ultraviolet light touched it, would that make the stone more fascinating or less? Share the thought below. Curious to see how many collectors would have recognized Hackmanite before the color change began. Hackmanite proves that rarity can hide behind unusual behavior, but sometimes rarity hides behind something even more deceptive, because the next gemstone spent years being mistaken for a completely different mineral. A stone many collectors would confidently misidentify. Ranked 9th, Jeremejevite. The stone most people misidentify. Some gemstones attract attention immediately. Jeremejevite rarely does. At first glance, it can appear surprisingly ordinary. The color is often pale, sometimes a soft sky blue, sometimes nearly colorless. Placed beside aquamarine or topaz, it may seem almost indistinguishable. That resemblance has fooled more than a few collectors. Because Jeremejevite has spent much of its history hiding behind other gemstones. The mineral was first identified in the late 19th century in Siberia, named after the Russian mineralogist Pavel Jeremejev. Early specimens were extremely limited, and for many years the mineral was known mostly to researchers rather than jewelers. Even today, its crystals often form as slender hexagonal prisms, sometimes transparent, sometimes faintly cloudy. Under the wrong lighting, the stone can look surprisingly modest, almost understated for something so rare. And that quiet appearance is exactly why Jeremejevite is so frequently misidentified. Gem traders encountering a pale blue crystal might easily assume they are looking at aquamarine. Others might mistake it for topaz or even colorless beryl. But the structure tells a different story. Jeremejevite is a borate mineral formed under very specific geological conditions that rarely occur in nature. Unlike the more common silicate gemstones, borate crystals require unusual environments rich in boron and aluminum, making the mineral far less common in the Earth's crust. The most important gemstone quality discoveries have come from Namibia, where a handful of exceptionally clear crystals revealed what Jeremejevite could truly become once properly cut. When faceted, the gem can display a delicate brilliance, subtle rather than dramatic, but unmistakably elegant under the right light. Still, even among collectors, Jeremejevite remains unfamiliar. Part of that mystery comes from how rarely it appears on the market. Another part comes from its quiet personality. Unlike gemstones that announce themselves with intense color or fire, Jeremejevite often blends into the background. A rare mineral disguised as something ordinary, and that disguise has allowed it to pass unnoticed more times than most people realize, which raises an interesting thought. If a gemstone could sit in a collection for years, mistaken for something far more common, would anyone recognize its rarity before a gemologist examined it closely? Curious how many viewers would have correctly identified Jeremejevite at first glance, especially before hearing its story. Jeremejevite shows how easily rarity can hide behind familiar colors. But the next gemstone took that confusion even further, because it wasn't discovered in a mine at all. It was discovered after it had already been cut into a gemstone. Ranked 8th, Taaffeite, the gem found by accident. Most gemstones enter the world of science in a predictable way. A mineral is discovered in a mine. Geologists study the surrounding rock. Samples are collected, cataloged, and eventually classified. Taaffeite did not follow that path. In fact, the mineral was identified in a finished gemstone long before anyone knew where it came from. The story begins in 1945 when an Irish gemologist named Richard Taaffeite was examining a collection of faceted stones purchased from a jeweler. Among them was a small, violet-colored gem that appeared almost identical to spinel, a mineral well known to collectors. At least, that is what it was assumed to be. But something about the stone felt slightly unusual. Under closer inspection, Taaffeite noticed a subtle optical difference. The gem showed double refraction, a property spinel does not possess. That small detail suggested the stone could not be spinel at all. The possibility seemed unlikely. Spinel had been studied for centuries, and no similar gemstone had ever been documented. Yet further testing confirmed the suspicion. The stone belonged to an entirely unknown mineral species. It was later named Taaffeite, in honor of the gemologist who first recognized the anomaly. Even today, the discovery remains one of the most unusual moments in gemological history. Taaffeite is the only gemstone first identified from a cut stone rather than from its natural crystal form in the ground, and its appearance does little to hint at such an extraordinary story. Most Taaffeite gemstones display soft shades of lavender, grayish-violet, or pale pink. The colors are delicate and understated, attractive, but far from dramatic. Placed next to more vivid stones, Taaffeite can seem almost quiet, yet rarity tells a very different story. Gem-quality Taaffeite crystals are exceptionally scarce, with known sources primarily in Sri Lanka and Myanmar. Even among those deposits, stones suitable for cutting are extremely uncommon. For decades after its discovery, only a handful of confirmed specimens were known worldwide, which makes Taaffeite a remarkable example of how easily rarity can hide in plain sight. A stone that once passed through a jeweler's hands as something ordinary turned out to represent an entirely new mineral. And that raises an intriguing question. How many gemstones sitting quietly in collections today might still be misidentified, waiting for someone to notice the detail that reveals their true identity? Curious to know how many viewers had heard of Taaffeite before this moment, or would have assumed it was simply spinel at first glance. Taaffeite proves that even experts can overlook something extraordinary, but the next mineral remained hidden for a completely different reason. Not because of misidentification, but because it forms in one of the most remote geological environments on Earth. Ranked 7th, Tugtupite, the Arctic mineral. Far in southern Greenland lies a geological formation known as the Illimassak complex, a place mineral collectors describe as one of the most unusual chemical environments on Earth. Hidden within those rocks is a gemstone that rarely appears anywhere else on the planet. That mineral is Tugtupite. Tugtupite is known for something far more unusual, where it exists. At first glance, this mineral rarely looks remarkable. In rough form, Tugtupite often appears cloudy, uneven, and slightly chalky. The color can range from pale pink to a muted reddish tone, sometimes mixed with white mineral inclusions. Compared to traditional gemstones, the appearance can seem almost modest, but Tugtupite is not defined by how it looks in a display case. It is defined by where it forms. The most significant deposits of Tugtupite are found in one of the most remote geological environments on Earth, the Illimassak complex in southern Greenland. This region is famous among geologists for producing unusual minerals that rarely occur anywhere else. The volcanic system that formed these rocks created chemical conditions rich in sodium, aluminum, and rare elements, allowing minerals like Tugtupite to crystallize in ways that are exceptionally uncommon. Because of this, gem-quality Tugtupite is already rare simply by geography. But the mineral holds another secret. Like Hackmanite earlier in this list, Tugtupite can display tenebrescence, a reversible color change triggered by ultraviolet light. Under UV exposure, the stone may shift toward deeper pink or crimson tones before gradually returning to its original color in normal lighting. It is a subtle transformation, but one that fascinates mineral collectors. In fact, the Inuit communities of Greenland have long been familiar with Tugtupite. In local traditions, the stone has sometimes been associated with themes of emotion and transformation, a reflection of its unusual color behavior. Yet despite its unique geological story, Tugtupite rarely appears in large faceted gemstones. The crystals tend to form in small sizes and can be fragile, which limits how often they are cut for jewelry. Most specimens remain in mineral collections, where the stone is appreciated not for brilliance, but for its rarity and unusual chemistry. Tugtupite represents a different side of the gemstone world. Not every rare mineral dazzles with light or fire. Some are valued because they exist only in the most specific corners of the planet, places where geology briefly aligned to create something that almost never forms, which leads to an interesting thought. If a gemstone could only be found in one remote Arctic geological complex, far from the traditional gemstone trade routes, would that rarity make it more fascinating to collectors? Curious to see how many viewers had encountered Tugtupite before, especially outside of mineral collections. Tugtupite shows how geography can shape rarity, but the next gemstone hides its uniqueness in a different way. Its secret only appears when the stone begins to move under light, because this mineral refuses to display just one color. Ranked 6th, Grandidierite, the stone with 3 colors. Rotate a Grandidierite crystal slowly under light, and something unusual begins to happen. The color refuses to stay the same. At one angle, the stone appears deep bluish green. Turn it slightly, and the color softens into green. Move it again, and parts of the crystal can appear almost colorless. It is not an illusion. It is the crystal structure itself interacting with light. This phenomenon is known as pleochroism, an optical property that allows certain minerals to display different colors depending on the direction from which they are viewed. Grandidierite happens to show this effect with remarkable strength. Yet despite this fascinating behavior, the mineral rarely attracts attention at first glance. Most rough crystals appear dark, uneven, and often heavily included. Without strong lighting, the surface can look surprisingly modest, especially when placed beside gemstones famous for brilliance or fire. That quiet appearance hides an extraordinary geological story. Grandidierite was first documented in southern Madagascar in 1902 and named after the French naturalist Alfred Grandidierite, whose research helped reveal the island's remarkable mineral diversity. For decades after its discovery, the stone remained almost entirely within the world of mineralogy. Crystals large enough and clear enough to be cut into gemstones were extremely uncommon. Many specimens appeared opaque, fractured, or heavily included, which meant collectors knew the mineral's name long before they ever encountered a faceted gem. Even today, transparent grandidierite remains rare. When suitable crystals are found and carefully cut, the gemstone reveals a quiet complexity that differs from the dramatic sparkle people usually associate with valuable gems. Instead of intense flashes of light, grandidierite offers something more subtle, a layered color, a shifting tone, a gemstone that looks slightly different each time it moves under light. For gemologists and collectors, that subtle behavior is part of the fascination. It demonstrates that rarity in the mineral world does not always announce itself with brilliance or bold color. Sometimes it appears in far quieter ways, hidden within the internal structure of the crystal itself. And that raises an interesting thought. If a gemstone revealed 3 different colors, depending on how it was rotated, but never displayed the dramatic sparkle most buyers expect, would that complexity make the stone more intriguing to study or easier for people to overlook? Curious how many viewers had heard of Grandidierite before encountering its unusual color behavior. Grandidierite reveals that rarity sometimes hides inside optical behavior, but the next gemstone takes the opposite approach. Instead of changing colors, it appears so dark and heavy that most people would never guess it is a gemstone at all. Yet it remains one of the rarest ever faceted. Ranked 5th, Serendibite, the heavy blue mystery. At first glance, a rough piece of serendibite does not look like a gemstone at all. The surface is often dark, sometimes a deep blue-green, sometimes nearly black. The crystal can appear dense and opaque, lacking the brightness most people associate with valuable gems. In a tray of rough minerals, it could easily be mistaken for an ordinary fragment of rock. Yet within the world of gemology, serendibite holds a very different reputation. It is considered one of the rarest gemstones ever cut. The mineral was first identified in 1902 in Sri Lanka, a country historically known for producing some of the world's most famous gemstones. But serendibite stood apart from the beginning. Unlike sapphire or spinel, which appear regularly in gem deposits, serendibite forms only under extremely unusual geological conditions. The mineral requires a precise combination of boron, aluminum, calcium, magnesium, and silica, crystallizing together in environments where these elements rarely occur in the right proportions. Because of that complexity, serendibite crystals are exceptionally scarce. For many decades after its discovery, only a small number of specimens were known to exist. Even fewer were transparent enough to be faceted into gemstones. When gem-quality stones do appear, they reveal colors that range from deep blue-green to rich teal tones. Under strong lighting, the stone can display a quiet depth that contrasts with its dark and unassuming rough appearance. But serendibite never became a mainstream gemstone. Part of that comes from its rarity. Another part comes from its subtle personality. Unlike diamonds or sapphires, serendibite does not immediately capture attention in a display case. Its beauty tends to emerge gradually, through depth of color rather than intense sparkle. For collectors, that quiet complexity is exactly what makes the stone fascinating. A mineral that looks so modest at first glance can turn out to be one of the rarest crystalline structures ever discovered in gemstone form. And that contrast is part of what keeps serendibite mysterious. Because without geological knowledge, most people would never suspect the stone's true significance. A dark crystal that appears ordinary, yet represents an extremely rare combination of chemistry and geological timing. It is a reminder that rarity in the mineral world does not always announce itself through appearance. Sometimes it hides in plain sight, and that leaves an interesting thought. If a dark, heavy crystal appeared in a tray of rough minerals with no label attached, how many people would recognize that it might be one of the rarest gemstones ever cut? Serendibite reminds collectors that rarity can hide behind an unremarkable appearance. But the next gemstone tells a different kind of story, a mineral whose entire existence was tied to one single quarry on Earth. Ranked fourth, Poudretteite, the stone from a single mine. High in the hills of Mont-Saint-Hilaire in Quebec, Canada, a quarry once produced something far more unusual than construction stone. Among the complex mineral veins hidden in that mountain, geologists discovered a crystal that few people had ever seen before, a delicate pink mineral that would eventually be named Poudretteite. At first glance, the rough crystals rarely looked extraordinary. Most appeared small, fragile, and uneven in color. Some were cloudy, others faintly pink with a glassy surface that lacked the immediate brilliance of more familiar gemstones. In mineral collections, early specimens were often valued more for scientific interest than visual beauty, but the rarity of Poudretteite was extraordinary. For many years, Mont-Saint-Hilaire was the only place on Earth where gem-quality Poudretteite had been found. That single quarry became one of the most important mineral localities in North America, producing dozens of rare species that exist almost nowhere else. Poudretteite itself was named after the Poudrette family, who operated the quarry for generations. Their work unknowingly uncovered a geological environment capable of forming minerals that rarely crystallize under normal conditions. The stone forms in alkaline igneous rock, a geological setting where unusual combinations of sodium, potassium, boron, and silica can interact. These environments are rare enough on their own, but the precise conditions required for Poudretteite to grow are even more uncommon. As a result, most crystals appear extremely small. Only a limited number have ever been large and clear enough to cut into faceted gemstones. When those rare crystals are properly polished, the stone reveals a soft pink color that can appear almost luminous under the right lighting. Yet even then, Poudretteite tends to remain understated. Its beauty is gentle rather than dramatic, a quiet tone of pink that lacks the intense saturation of rubies or spinels. To many observers, the stone might seem subtle, even delicate, but collectors understand the deeper story. A gemstone tied so closely to a single geological location carries a kind of rarity that few minerals share. When the conditions that created it occur only once, or almost once, in the Earth's crust, every specimen becomes part of a very limited chapter in geological history. And that connection raises an intriguing question. When a gemstone's entire story is linked to one mountain, one quarry, and one moment in geological time, does that make the stone itself more extraordinary than its appearance suggests? Because sometimes rarity is not about brilliance or color. Sometimes it is about where the Earth allowed a mineral to exist at all. Poudretteite proves how rare a gemstone can become when its source is limited. But the next mineral pushes rarity even further. For years, only a handful of gem-quality examples were known anywhere on the planet, a gemstone many collectors may never encounter. Ranked third, Musgravite, the stone few have ever seen. In the world of gemstones, rarity is often discussed in terms of deposits, production, or market availability. Musgravite exists on a completely different scale. For many years after its discovery, the number of known gem-quality musgravites could be counted on one hand. The mineral was first identified in 1967 in the Musgrave Ranges of South Australia, a remote region of rugged desert mountains. Named after that location, Musgravite belongs to the Taaffeite mineral family, a group already known for its extraordinary scarcity. But Musgravite pushed that rarity even further. The geological conditions required to form this mineral are remarkably specific. Musgravite crystallizes in environments rich in beryllium, magnesium, aluminum, and oxygen, combined under temperatures and pressures that rarely align within the Earth's crust. When those elements fail to meet under the right circumstances, the mineral simply does not form. Because of this, Musgravite deposits are extremely limited. Beyond Australia, only a few additional locations have produced specimens, including Sri Lanka, Madagascar, Tanzania, and Greenland. Even in those regions, crystals large enough and clear enough for gemstone cutting remain exceptionally uncommon. At first glance, the mineral does little to suggest such extraordinary rarity. Most rough crystals appear grayish-green, sometimes slightly brown or violet, often with surfaces that seem subdued rather than dramatic. In their natural form, Musgravite crystals rarely display the brilliance people expect from gemstones. Yet when a transparent specimen is carefully cut and polished, the stone reveals a quiet elegance, a subtle play of color that may shift between gray-green, olive, or soft violet depending on the light. It is not a gemstone built around spectacle. Instead, Musgravite fascinates collectors because of how rarely it appears at all. In fact, for decades after its discovery, many gemologists studied Musgravite primarily through scientific papers and mineral samples, rather than faceted stones. The opportunity to examine a gem-quality specimen was simply too uncommon. That rarity has turned Musgravite into something of a legend among mineral collectors. Not because it dazzles immediately, but because so few people ever encounter it. And that raises an unusual perspective. If a gemstone existed in such small numbers that most collectors might never see one in person, would its rarity make it more fascinating than stones known for brilliance alone? Because in the quiet corners of mineralogy, rarity sometimes becomes the most powerful story a gemstone can tell. Musgravite belongs to a category of minerals defined by extreme scarcity. Yet the next gemstone forms under conditions just as unlikely, hidden within volcanic desert rock in the American Southwest. A crystal so small that most specimens never become gemstones at all. Ranked second, red beryl, the desert rarity. Across the volcanic desert landscape of Utah's Wah Wah Mountains, small red crystals occasionally appear within pale rhyolite rock. At first glance, they do not look impressive. Most are tiny, often no larger than a few millimeters. Their surfaces can appear rough, fractured, and irregular, more like fragments of mineral growth than gemstones waiting to be cut. Yet those crystals belong to one of the rarest members of the beryl family, red beryl. While emerald and aquamarine are well-known varieties of beryl found in many parts of the world, red beryl forms under an extremely narrow set of geological conditions. It requires volcanic gas-rich rhyolite, combined with the presence of beryllium and trace amounts of manganese, crystallizing in an environment where pressure, temperature, and chemical composition align almost perfectly. Those conditions rarely occur together, and when they do, the crystals that form are usually extremely small. That is why the vast majority of red beryl crystals are never cut into gemstones. Most remain mineral specimens, admired for their rarity rather than their size. Even in the Wah Wah Mountains, the most famous source, only a tiny fraction of discovered crystals grow large and clean enough for faceting. When a suitable crystal is found, however, the result can be striking. Faceted red beryl displays a vivid red color, sometimes compared to ruby, though its tone often carries a slightly purplish or raspberry hue. In good lighting, the stone reveals the crisp brilliance typical of the beryl family. But the real story of red beryl is not color, it is geography. Unlike many gemstones that appear across multiple continents, red beryl has remained closely tied to a single remote region of the American desert. For collectors, that exclusivity adds another layer of fascination. Each crystal represents a moment when volcanic chemistry briefly aligned to create something that almost never forms. In fact, gemologists often note that fine red beryl gemstones are significantly rarer than many varieties of diamond, not because diamonds are common, but because red beryl occurs in such limited geological circumstances. Still, most people encountering a rough crystal would never suspect its significance. A small red fragment embedded in volcanic rock rarely announces itself as a rare gemstone, and that contrast is part of what makes red beryl remarkable. A gemstone born from desert volcanism, hidden inside rhyolite formations, and discovered only by those willing to search through one of the harshest geological landscapes in North America, which leaves an intriguing thought. If a gemstone forms almost entirely within a single desert mountain range, does its rarity come from its beauty, or from the unlikely conditions that allowed it to exist at all? Red beryl is already among the rarest gemstones known, but for decades, one mineral stood above all others. A gemstone so scarce that scientists once believed only 3 crystals existed on Earth. That mineral would completely redefine what rarity means in the gemstone world. In first place, Painite, the stone that redefined rarity. For much of the 20th century, the mineral world believed something almost impossible. Somewhere on Earth, there existed a gemstone so rare that only 3 crystals were known to science. Not 3 mines, not 3 deposits, 3 crystals. That mineral became known as Painite. The story begins in Myanmar in the 1950s, when British mineralogist Arthur C.D. Payne encountered an unusual reddish-brown crystal within the gem-rich gravels of the region. At the time, it was simply another curious specimen among many stones moving through local markets. But closer examination revealed something extraordinary. The crystal did not match any known mineral species. After years of analysis, the mineral was officially classified and named in honor of the man who first brought it to scientific attention. Yet what truly astonished gemologists was not just its structure, it was its rarity. For decades after its discovery, Painite remained almost mythical within the world of mineralogy. Collectors read about it in scientific journals. Gemologists studied its crystallography in textbooks, but very few people had ever seen one in person. The reason lies in its chemistry. Painite forms through an extremely complex interaction of calcium, zirconium, aluminum, boron, and oxygen, combined within a geological environment that almost never occurs. When even one of those elements is absent, the mineral cannot form. Nature rarely allows such precise combinations, and when it does, the crystals tend to grow small and heavily included, often appearing dark or unremarkable in rough form. At first glance, a raw Painite crystal can look surprisingly modest, a brownish or reddish mineral that hardly suggests its legendary status. Yet once properly cut and polished, the stone reveals something very different. Faceted Painite can display a deep red to reddish-orange color, sometimes with subtle flashes of warm copper tones under light. The brilliance is quiet but unmistakable, revealing a gemstone that hides complexity beneath an understated exterior. Over time, additional crystals were discovered in Myanmar, and the number of known specimens slowly increased. Even so, gem-quality Painite remains extraordinarily scarce compared with most gemstones encountered in the trade. But perhaps the most remarkable aspect of Painite is the lesson it offers. In a world where beauty often defines value, Painite reminds collectors that rarity can exist far beyond visual first impressions. A stone that once appeared ordinary, even dull, turned out to represent one of the most improbable mineral formations ever discovered on Earth. And that realization changed how gemologists think about rarity itself, because sometimes the rarest gemstone in the world does not announce its importance with brilliance or color. Sometimes it sits quietly in a tray of minerals, waiting for someone to recognize what it truly is. Some of the rarest gemstones on Earth don't look extraordinary at first glance. From color-changing minerals like Hackmanite, to the accidental discovery of Taaffeite, to the legendary rarity of Painite, these stones reveal something surprising. In the mineral world, rarity doesn't always look impressive. Sometimes the most ordinary-looking stones turn out to be the hardest to find. Which gemstone from this list surprised you the most? Share it in the comments below, because sometimes the rarest things on Earth are the ones almost no one recognizes at first glance.